Noise pollution. It's all around us. You hear it every day in traffic, loud music, and in the workplace from noisy machines. Do you understand that the noise of our everyday lives could affect hearing loss in the future? According to OSHA, if you need to raise your voice to speak to someone just 3 feet away, noise levels might be too high. This training program will look at the following areas dealing with noise and hearing. Introduction to hearing conservation. Scope and application. Definitions. The ear. Hearing loss. Types of hearing loss. Effects of excessive noise exposure. Evaluating noise exposure levels. Hearing conservation program. Hearing protection. The Center for Disease Control, or CDC, estimates that 22 million workers are exposed to potentially damaging noise while at work each year. Whether you work at a sports venue, on an airport tarmac, or operate a jackhammer or a saw, hearing loss is preventable. Noise may be a problem in your workplace if you ever hear ringing or humming in your ears after you leave work. Another symptom is not being able to hear a coworker an arm's length away, or if you experience temporary hearing loss after leaving work. All these issues are preventable, and your employer should be made aware of any situation that presents a noise-related problem. The incidence of noise-induced hearing loss can be reduced or eliminated through the successful application of engineering controls and hearing conservation programs. When controls are not sufficient or feasible, employers must implement an effective hearing conservation program. Noise, or unwanted sound, is one of the most pervasive occupational health problems. It is a byproduct of many industrial and construction processes. Sound consists of pressure changes caused by vibration or turbulence. These pressure changes produce waves emanating away from the turbulent or vibrating source. Exposure to high levels of noise causes hearing loss and may cause other harmful health effects as well. The extent of damage depends primarily on the intensity of the noise and the duration of the exposure. The first steps in preventing hearing loss is recognizing the problems. Noise hazards are addressed in the OSHA standards in both general industry and the construction industries. OSHA requires employers to determine if employees are exposed to excessive noise levels and for how long. When employees are subjected to excessive noise levels, feasible administrative or engineering controls, such as soundproofing, must be used. When controls are not sufficient or feasible, employers must implement an effective hearing conservation program. There are several common definitions used by professionals to determine the effects of noise on the human ear. Sound is the physical phenomenon that stimulates our sense of hearing. It is an acoustic wave that results when a vibrating source, such as machinery, distributes an elastic medium, such as air. Sound, basically, is a pressure that exerts force onto the ear. Frequency is measured in units known as a hertz, and is the number of waves or vibrations that occur per second. Hertz is abbreviated Hz. The decibel is the unit used to measure sound levels and abbreviated as dB. Sound measurements are taken while standing near the sound. An 8-hour time-weighted average, or TWA, of 85 decibels is considered the threshold by OSHA to institute hearing conservation programs. Your ear allows you to hear sound and noise. Sound is created when acoustic waves are felt by the eardrum. The number of times the waves or vibrations are felt in the eardrum is known as the frequency of the sound. The human ear can perceive frequencies between approximately 20 and 20,000 hertz, but the range varies greatly between different people. The ability to perceive higher frequencies decreases as people age. The ear is made up of three main parts. External outer ear receives an acoustic wave and directs it to the eardrum. The eardrum is a membrane covering the middle ear canal. Air-filled middle ear converts and amplifies the modified acoustic wave into vibration of the eardrum and transmits to the inner ear. Fluid-filled inner ear transforms the mechanical movement of the wave into nerve impulses that travel to the brain, which perceives and interprets the impulse as sound. When one is exposed to extremely loud sounds, or loud sounds that last a long time, damage may occur to components of the inner ear, resulting in permanent or temporary hearing loss. This is known as noise-induced hearing loss, or NIHL. Noise-induced hearing loss is one of the most common occupational illnesses. Many times this hearing loss is ignored because there are no visible effects. It tends to develop gradually, and except in rare cases, there is no pain. The loudness of sound is measured in decibels. For example, normal conversation is 60 decibels, and city traffic noise can be 85 decibels or above, depending where you are. Noises that can cause noise-induced hearing loss include motorcycles, woodworking tools, machinery, firecrackers, firearms, and airplanes. Exposure to noise levels over a long period of time at or above 85 decibels can cause hearing loss. The louder the sound, the shorter the exposure time it takes to cause hearing loss. Most people do not feel pain from noise levels until it reaches approximately 120 decibels. The range between 85 and 120 decibels is a danger zone where damage can occur and not be realized. Sounds may become distorted or muffled if NIHL exists. The person may also find it difficult to understand speech. Hearing loss is often accompanied by ringing, buzzing, or roaring sounds in the ear. This is known as tinnitus and is the most common symptom of NIHL. Tinnitus usually indicates the noise level is too loud. Noise-induced hearing loss does not discriminate against age. There are many known cases, from children to the elderly. Exposure can happen in a variety of places, such as the work environment, recreational activities, or at home. NIHL is 100% preventable with training and the proper use of hearing protection. Once someone has NIHL, though, it is permanent and irreversible. Hearing loss is usually classified as either conductive or sensory neural. A combination of both types is possible. Conductive hearing loss is a result of any condition in the outer or middle ear that interferes with sound passing to the inner ear. This type of hearing loss generally involves a reduction in sound level or the ability to hear soft sounds. Excessive wax buildup in the auditory canal or fluid in the middle ear are examples of conductive hearing loss. Work-related conductive hearing loss is not common, although it may occur occasionally as a result of accidents involving an eardrum rupture caused by a blow to the head, explosions, penetration of the eardrum by a sharp object, or fragment. Many conductive hearing losses are reversible through medical or surgical treatment. Chronic noise-induced hearing loss is a permanent sensory neural condition that cannot be treated medically. Such loss can be mild, moderate, or severe, including total hearing loss. Sensory hearing loss is associated with irreversible damage to the inner ear or the nerve pathways from the inner ear to the brain. It is initially characterized by declining sensitivity to higher frequency sounds, usually at frequencies above 2000 Hz. A combination of both conductive and sensory neural hearing loss can occur. This type of hearing loss is usually referred to as a mixed hearing loss. Even though noise-induced hearing loss has no visual effects or any pain, there are some very real consequences. The act of communicating is often negatively affected and diminishes over time. A progressive loss of socialization and responsiveness to the environment also occurs quite often with NIHL. When hearing loss is above 2000 Hz, it affects the ability to understand or discriminate speech. As the loss moves into lower frequencies, it begins to affect the ability to hear sounds in general. The effects of noise can be simplified into three general categories: primary effects, effects on communication, and other effects. The primary effects of excessive noise exposure may include acoustic trauma, tinnitus, and threshold shifts, both temporary and permanent. Acoustic trauma refers to a temporary or permanent hearing loss due to a sudden intense acoustic or noise event, such as an explosion. Tinnitus is described as the condition of ringing in the ears. Individuals often describe the sound as a ring, buzz, hum, roar, or whistle. The predominant cause of tinnitus is long-term exposure to high sound levels, though it can also be caused by short-term exposure to very high sound levels, such as gunshots, non-acoustic events such as a blow to the head, dietary issues, stress, jaw joint disorders, debris on the eardrum, or prolonged use of aspirin or other drugs may also cause tinnitus. Many people experience tinnitus during their lives. Most of the time, the sensation is only temporary. However, it can be permanent and debilitating. A noise-induced temporary threshold shift, NITTS, is a temporary loss in hearing sensitivity. With NITTS, hearing sensitivity will usually return to the pre-exposed level in a matter of hours or days, assuming that there is not continued exposure to excessive noise. A noise-induced permanent threshold shift, NIPTS, is a permanent loss in hearing sensitivity due to the destruction of sensory cells in the inner ear. This damage can be caused by either long-term exposure to noise or acoustic trauma. Excessive noise exposure can have a negative effect on a worker's ability to communicate, as well as their job performance. The excessive noise exposure can cause individuals to feel isolated from coworkers and become easily annoyed. The noise can cause lack of concentration, leading to higher absenteeism and accidents. Other effects of excessive noise may include stress, muscle tension, ulcers, increased blood pressure, and hypertension. Many times, employees will not know the reason behind their changed behaviors. The first step in solving a noise problem is to define it. Determining exposure levels is necessary to implement a successful hearing training program. There are various indicators which may point to a noise being a problem in the workplace: conditions that make normal conversation difficult, adverse reactions or behaviors in the workplace, and reduced job performance or production. One of the first things you should do is perform a walk-around survey. Sound level meter measurements and duration of exposure estimates are sufficient to determine if additional monitoring is needed. When the results of the walk-around survey indicate unsafe noise levels, like a time-weighted average TWA exposure of 85 decibels or more, then additional noise monitoring is necessary. First, establish a sampling protocol to measure the sound levels. Inform and educate all employees about the noise monitoring protocol and procedures. Sample noise exposures of representative employees and their work areas. This should be done in all areas that are potentially overexposed. Conduct sampling for an appropriate length of time to establish whether exposures are above permissible limits. TWA exposures at or above 85 decibels, also referred to as the action level, require a hearing conservation program. TWA exposures exceeding the permissible exposure level, or PEL, require feasible engineering and/or administrative controls be implemented. There are 3 different instruments that are generally used to measure sound. The first is a sound level meter. A sound level meter, SLM, is the basic instrument for investigating noise levels. Next is a dosimeter. Like a sound level meter, a noise dosimeter can also measure sound levels. However, the dosimeter is actually physically worn by the employee in order to determine the personal noise dose during the work shift or sampling period. Lastly, octave band analyzers are sound level meters which amplify a microphone signal and feeds it into a band pass filter. Whenever employee noise exposures equal or exceed an 8-hour time-weighted average sound level of 85 dBA, OSHA requires a continuing effective hearing conservation program be administered. OSHA states specific hearing conservation program requirements for general industry, but not for the construction industry. In order for the employer to know who must wear hearing protection, and to be able to evaluate the adequacy of the hearing protection used, the noise created by different machines and operations should be known and recorded. It is the responsibility of the employer to implement a noise monitoring program as part of the hearing conservation program. The hearing conservation program is only necessary if test results show that employees are exposed to an 8-hour time-weighted average of 85 decibels. Monitoring must be repeated whenever there is a change in production, process equipment, or controls that increase noise levels. If additional employees are exposed or hearing protection is rendered inadequate, then testing must be conducted. Employees must have the opportunity to observe any tests conducted. The Hearing Conservation Program requires employers to monitor noise exposure levels in a way that accurately identifies employees exposed to noise at or above 85 decibels averaged over 8 working hours, or an 8-hour time-weighted average, or TWA. Employers must monitor all employees whose noise exposure is equivalent to or greater than a noise exposure received in 8 hours, where the noise level is constantly at 85 decibels. The exposure measurement must include all continuous, intermittent, and impulsive noise within an 80 decibel to 130 decibel range, and must be taken during a typical work situation. This requirement is performance-oriented because it allows employers to choose the monitoring method that best suits each individual situation. The method used to notify employees is left to the employer's discretion. Employers must carefully check or calibrate instruments used for monitoring employee exposures to ensure that the measurements are accurate. Calibration procedures are unique to specific instruments. Employers should follow the manufacturer's instructions. Audiometric testing monitors an employee's hearing over time and will detect any changes. A baseline test must first be performed to compare subsequent tests. The presence of a threshold shift can be determined by such testing. This also provides an opportunity for employers to educate employees about their hearing and the need to protect it. Employers must establish and maintain an audiometric testing program for all employees exposed at or above the action level of 85 dBA. The program must be provided at no cost to employees. All audiometric tests must be performed by a licensed professional. Employees should provide the examiner with any history of ear disease, treatment, and current conditions. Exams must be performed annually to determine if the employee is experiencing any hearing loss due to exposure or noise. If a threshold shift is present, the employer must provide additional means of hearing protection. As with other forms of personal protective equipment, hearing protection devices, HPDs, are considered the last option to control exposure to noise. HPDs are generally used during the necessary time it takes for engineering and administrative controls to be enacted, or when such controls are not feasible. Employers must make HPDs available to all employees exposed at or above the action level. These must be provided at no cost to employees and must be replaced as necessary. Employees must be given the opportunity to select their HPDs from a suitable variety. Generally, this should include a minimum of 2 devices representative of at least 2 different types. The employer must provide training in the use and care of all HPDs provided to employees, and must ensure proper initial fitting of HPDs and supervise their correct use. Employers should institute an annual training program for all employees with noise exposures at or above the action level. The employees must be trained to understand the effects of noise on hearing, the purpose, use, and characteristics of different types of HPDs, and know how to select, fit, use, and care for them. The employer is responsible to keep records of the employees who have received the training. These records must include the name of employees trained, job classifications of each employee, date of training, and personnel performing training. Other records to be kept include all noise measurements, audiograms, and training. The forms of audiograms must include name and job classification of the employee tested, date of audiogram, the examiner's name, date of the last acoustic or exhaustive calibration of the audiometer, employee's most recent exposure assessment. Noise exposure measurement records must be kept for 2 years. Audiometric test records must be retained for the duration of an affected employee's employment. All materials that are kept pertaining to hearing conservation must be readily available for employees, former employees, representatives, and the OSHA Assistant Secretary upon request. These records must be transferred to any successor employer if the current employer ceases to do business. The successor employer will then be responsible for maintaining the records of the remainder of the period required. There are many types of hearing protection. Some are hybrids of the existing protection that aid in comfort and convenience. The 4 basic types of ear protection include foam plugs, pre-molded plugs, canal caps, and earmuffs. The best hearing protector is one that is comfortable, convenient, and one that you can wear every time you are in an environment with hazardous noise. Foam earplugs are designed to expand and fit the contours of the ear canal. To insert them into the ear, simply roll them between your thumb and fingers or in the palm of your hand. The final result should be a smooth tube, thin enough so that about half the length will fit easily into your ear canal. The foam will then expand to fit the canal. Pre-molded plugs are usually made from silicone, plastic, or rubber, and usually come in many different sizes. The major problem with these is that both ear canals may not have the same shape. A person may need a different size plug for each ear. The plug should seal the ear canal without being uncomfortable. To insert this type of plug, you must reach over your head with one hand and pull back on the ear to open the canal more. Then with the other hand, place the plug in the canal, gently rocking it back and forth until the canal is sealed. Canal caps often resemble earplugs on a flexible plastic or metal band. The main advantage canal caps offer is convenience. When it's quiet, employees can leave the band hanging around their necks. They can quickly insert the plug tips when hazardous noise starts again. Some people find the pressure from the bands uncomfortable. Not all canal caps have tips that adequately block all types of noise. Generally, the canal cap's tips that resemble standalone earplugs seem to be the most efficient in blocking noise. Ear muffs are manufactured in many different models to fit most people. These resemble audio headphones. They block noise by completely covering the outer ear. Some muffs have electronic components that cancel sound and/or allow the wearer to communicate with others. Ear muffs lose their effectiveness when the wearer has a thick beard or sideburns. The hair prevents the muffs from sealing against the area surrounding the ear. In some environments, the earmuffs can feel hot and heavy. The ear is a sensitive part of the body that is very susceptible to damage by sound vibrations. Damage can be caused by exposure to loud sounds for a continuous period of time or very loud sounds. There are many types of hearing protection available today. When employees are properly trained and use the proper hearing protection, hearing loss is 100% preventable. The most effective hearing protection is the one that fits properly and is comfortable. Be safe. Wear protective hearing protection when it is necessary. Your ears will thank you.